Hello everyone, a very good evening all of you and a very warm welcome to you all to this faculty driven platform that is Resultant. So first of all, please do let me know if my audio and visual quality are fine so that we can start this mini mock test for thermal engineering. Am I properly audible and visible to all of you? Can you guys hear me? Yes? Give me yes. So as you all know that HPCL opportunity is one of the golden opportunity for all the mechanical engineers, and the syllabus is more or less similar to the GATE syllabus. So it will be an added advantage if you prepare for the HPCL thoroughly and appear for this examination with your full efforts. Yes, I hope I am properly audible and visible to all of you. So shall we start? Can you guys hear me? Yes. So I am having around 15 to 20 questions and mixed up questions. Some questions are from the fluid mechanics. Some of the questions are from the heat transfer, and some of the questions are from the basic thermodynamics and its applications. Right? So keep your pen, notebook and calculator and try to solve all the questions before I share the solution. Then you will develop the confidence as well as you will improve your thought process, you will improve your time management and accuracy. So with this note, let us start the session. Hi Vaibhav, good evening, welcome. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalam Walaikum, Vanakkam. Please get yourself settled down fast and sit back, relax and try to utilize this session as much as you can. So before I start the session, let me quickly introduce myself. I am mechanical engineering graduate from IIT Delhi, having more than 12 years of teaching experience and also cleared engineering services examination which is conducted by UPSC and worked in Steel Authority of India Limited for a couple of years. And you can connect with me through the official mail ID which is already there, and you can join me on the Telegram also. My Telegram channel is Mechanical by Chandrasekhar. The link is also shared at the bottom of this screen. So if you join me on the Telegram, you will be able to connect with me and your fellow colleagues who are sincerely preparing for the various competitive examinations, and that will be going to help you a lot in having your preparation more smooth and result oriented. Yes, very important announcement before we start our session. We are going to reveal a very big surprise for you all very soon. So stay tuned with us. Do subscribe our Byju's YouTube, Resultant's YouTube channel for the updates which are on your way, which will help you to prepare better for your all the competitive examinations. And there is one MSQ series. As you all know, MSQs are very crucial part nowadays for GATE examination. After the inclusion of MSQs, so many students are afraid of MSQs. So to make these MSQs simple, easier, comfortable for you, Abhinav Negi sir is running a series for MSQs. Every day he is discussing some MSQs, and the timing on the YouTube, same YouTube platform only, and the timing is 8 p.m. all right. And if you want to practice more numericals related to the HPCL which are having the sync with the HPCL examination, which are having the similar type of difficulty level, you can purchase our test series only for $399, and along with that you will be getting the practice test, full length test, free of cost, and the previous year questions also. It is not a big amount, but yes, it is very, very beneficial if you are targeting for HPCL examination. All right, and we are running the paid courses also, as you all are aware. If you want to be part of our faculty driven platform, if you want to make this resultant as your part of the preparation journey, definitely you can join our paid courses which have recently started. So let us start. I want everyone to keep on sharing your answers and keep on asking your doubts. The first question is from the hydraulic machine. Yes, everyone, read the question carefully and try to give me the answer for this one. In an inward flow reaction turbine, there are two types of reaction turbine. One is Francis, another is Forneron. Francis is inward radial flow and Forneron is outward radial. Radial flow, there are two types of radial flow turbines. One is inward radial flow, another is outer radial flow, and the third one is axial flow reaction turbine. But we are talking about the radial flow only. Inward radial flow. Inward flow means radial flow. So in radial flow turbine, what happens? In the radial flow turbine, these are the blades. The fluid is flowing radially inward. Yes or no? The fluid is flowing in radially inward direction. In outward flow turbine, the fluid is flowing radially outward. So the fluid flows parallel to the axis of the wheel. That is axial flow. In axial flow turbine, the fluid flows parallel to the axis of the wheel. So A cannot be correct. The water enters the center of the wheel and then flows towards the outer periphery. That is outward radial. This is outward radial. Forneron. No. The water enters the wheel at the outer periphery. Yes, that is true. And then it flows towards the center of the wheel. C is the correct answer, isn't it? And option D says the flow of water is partially radial and partially axial. That is called as mixed flow turbine. When the flow is partially radial and partially axial, it is known as mixed flow. Yes, Reyes. C is the correct answer. Well done. Good, good, good. Everybody, please keep on sharing your answer. It will help me to understand whether your concepts are clear or not. And it will also help you to know your weak areas, your strong areas, so that you can work upon those which are weaker and you can perform better in your examination. Yes, the next question is from the HT, heat transfer. For the fluid having Prandtl number equal to 6.54 at 18 degrees Celsius. Prandtl number is given as 6.54. If the thermal boundary layer thickness is 8 centimeter, what will be the corresponding boundary layer thickness for the fluid? So Prandtl number, based on the value of Prandtl number, if it is greater than 1, less than 1 or equal to 1, there are three possibilities. If the Prandtl number is less than 1, then delta V is less than delta T. Yes or no? Velocity boundary layer thickness is less than thermal boundary layer thickness. If equal to 1, then velocity boundary layer is equal to thermal boundary layer thickness. If it is greater than 1, then velocity boundary layer thickness is greater than thermal boundary layer thickness. These are for laminar, or these are for laminar flow. For turbulent flow, delta V is always equal to delta T irrespective of Prandtl number, not a function of Prandtl number. If the flow is turbulent, then it does not matter whether the Prandtl number is less than, equal to or greater than 1. Prandtl number is the property of the fluid. It is the property. So can you let me know? It is the property of the fluid. So what will be the velocity boundary layer thickness for the fluid? So we can say delta V by delta T is equal to Prandtl number to the power 1 by 3. Yes. Delta V by delta T is equal to Prandtl number to the power 1 by 3. Can you get me the answer? What will be the answer? Good evening, Sarath. Welcome. So it will be delta V is equal to delta T, thermal boundary layer thickness is 8 into Prandtl number 6.54 to the power 1 by 3. So if you take 6.54 to be around 8, let us take it around 8. So 8 into 8 to the power 1 by 3, it should be less than this. Delta V should be less than 8 into 8 to the power. So it should be less than 16 centimeter. It should be slightly less than 16 centimeter. Yes or no? It will be less than 16 centimeter. This is how you can round off your calculations. It is very, very important. If the calculator is not allowed, it is very important for you to understand how to round off your calculation nearest to the correct answer. So 14.96 will be the right answer. Well done. Good, good, Shreyas, Priyanshu. Well done, guys. Keep it up. Let us move to the next one. The next one is theoretical. In a reaction turbine, the draft tube is used. Why do we use the draft tube? And the draft tube is used only in the reaction turbine. Impulse turbine does not have a draft tube. It is not required for the impulse turbine to have a draft tube. Draft tube is used to recover the pressure. The pressure at the reaction turbine outlet is very, very low because it is the pressure energy which gets converted into mechanical energy. So there is a huge drop in pressure at the outlet of the reaction turbine, and that is the reason there are more chances, or there are chances of cavitation at the outlet of the reaction turbine. So to recover that pressure, draft tube is a diffuser passage which is attached to the outlet of the reaction turbine. So in diffuser passage, area is continuously increasing. So the velocity will decrease and the pressure will increase. So pressure at the draft, at the end of the diffuser passage or the draft tube is higher. So what is the correct answer? It is used to run the turbine full? No. It is used to prevent the air from entering the turbine? No. It is used to increase the effective head of water. Draft tube, by use of the draft tube, the available head is utilized more efficiently. Available head, it increases the available head, H, to increase the efficiency. Its efficiency. Yes, C will be the correct answer. Yes, that is correct. C will be the right answer. To transport the water to the downstream. No, even if there is no draft tube, that water will definitely transport to the downstream only. C will be the correct answer. Well done, well done. Good, good, Vaibhav. Shreyas. Good. Keep it up, guys. Keep your momentum. Keep your energy. Keep your motivation high. The next one is the ratio of kinematic viscosity to thermal diffusivity. Very simple. What is that dimensionless number called, which is the ratio of kinematic viscosity? Unit of kinematic viscosity is meter square per second, and unit of thermal diffusivity is also meter square per second. So the ratio is a dimensionless number. What is that? If we talk about the Grashof number, which is used in natural convection or free convection, the ratio of buoyant force to viscous force is Grashof number. If we talk about Mach number, that is used in our fluid mechanics, Mach number is the ratio of inertia force to elastic force, under root of that, or we can say V by C, Mach number. Nusselt number is the ratio of conductive thermal resistance to convective resistance for the fluid, because fluid is having conduction also, convection also. There is a conduction in the fluid in the no slip region. इलेक्ट्रिकल इंजीनियर के लिए नई रिया में, व्हाट इज योर नेम, निंगतालाकबे, sorry to say, but this platform is only for civil and mechanical engineers. So all the sessions for civil and mechanical engineers will be there on our platform. All right. So we are fully dedicated to help the civil and mechanical engineering students only. It is the Prandtl number, which is the ratio of kinematic viscosity. Kinematic viscosity is also known as momentum diffusivity. We also call it as momentum diffusivity. So the ratio of kinematic viscosity to thermal diffusivity is the Prandtl number. It is the property. This dimensionless number is the property. Yes. So option B is the correct answer. All right. Let us move to the next one. Next question on your screen. Read it carefully. Very beautiful question. There might be slight calculation in the question, so you should be able to deal with the calculation. There is a 0.5 meter diameter pipe which bifurcates at a Y section into two branches. This is the main branch. Let me call it as D is the diameter, and there are two branches which are D1 is 20 centimeter and D2 is 40 centimeter in diameter. If the flow rate of water in the main pipe, if the rate of flow in the main pipe is 0.6, discharge is 0.6 meter cube per second, and through the smaller diameter pipe, which is smaller diameter pipe D1, so Q1 is 0.25, then what is the velocity of flow in the bigger pipe? So we need to find out V2. Can you solve it? Yes. There is a original pipe, it is bifurcating. So Q is equal to Q1 plus Q2 according to continuity equation. So we can say Q2 will come out to be, what is Q2? Q minus Q1. What is Q1? Q is 0.6 minus 0.25. So it will be 0.35. This is 0.35. Yes. So Q2 is equal to pi into R2 square into V2. We need to find out V2. So V2 is equal to Q2 0.35 divided by 22 by 7 into R2 square. What is R2? D2 is 40 centimeter, R2 is 20 centimeter, and 20 centimeter is 0.2 square. Can you solve it? 0.35 into 7 upon 22 into 0.04. Yes. So it will be 35 into 7 upon 22 into 4. Can you solve it? it is slightly greater than 8. So it is 56 by 22. Sorry, it is close to 9. It is close to 9. So it is slightly less than 63 by 22. So slightly less than 3. It is slightly less than 3. Isn't it? So 2.785. The nearest option is 2.785. Yes. .785. Is this clear? The next one, from the heat transfer, what is the shape factor of a hemispherical body which is placed on a flat surface with respect to itself? Yes, can you solve it? There is a flat surface and there is a spherical body like this. We need to find out the shape factor of the spherical body. This is the spherical surface. Shape factor of the spherical surface. Let me call it as surface 1. This is, let us say, surface 2. So we need to find out F11. Can we say F11 plus F122 is equal to 1, and F221 plus F222 is also equal to 1 from the enclosure theorem, and 2 is a flat surface. For the flat surface, self shape factor is 0. For the flat surface, self shape factor is 0, and A1 F122 is equal to A2 F221. So from here we can say F122 is equal to A2 by A1. So F11 is equal to 1 minus F12, that is 1 minus A2 by A1. What is the value of A1? A1 is equal to 2 pi r square. What is the value of A2? A2 is equal to pi r square. So it is 1 minus 2 pi A2. Sorry, A2 is pi r square. Pi r square by 2 pi r square. So the answer for F121 is equal to 1 minus 1 by 2, that is equal to 0.5. 0.5, that has nothing to do with the radius. It is independent of radius. 0.5 will be the self shape factor of hemispherical cavity. 0.5 is a constant value. It is a fixed value for all the hemispherical cavity. All right, clear? So if you want any kind of support from the resultant team, for mechanical students, there is a number mentioned. You can take the screenshot or you can note down these numbers and the email ID for all type of support and help for your preparation. Let us move to the next one. Next question on the screen from the thermodynamics. Next one is from the thermal engineering. Which of the following is extensive property? What is extensive property? Extensive property is the one which depends on mass or size or extent of the system. It is also known as extrinsic property. Extrinsic property. There is an intensive property. Intensive property which are independent of mass. Independent of mass or size of the system. Intensive properties are independent of mass. So pressure is intensive property. Pressure does not depend on mass. Temperature is intensive property. Density neither depends on mass nor volume. People have a doubt. Density is equal to mass upon volume. Actually, mass of a substance is directly proportional to volume. So mass and volume are dependent on each other. Density depends on temperature and pressure. So pressure, temperature and density all are intensive property. They are independent of mass. It is only the volume which depends on mass of the system or size of the system. More will be the size or more will be the mass. We can say from here, mass and volume are directly proportional to each other. So it is volume. Energy, all type of energy are are extensive property. Kinetic energy half mv square, potential energy mgh depends on mass. All type of energy are extensive properties. So volume and energy are extensive. Pressure, density, temperature, these are all intensive properties, right? Now the next one. Who will be going to solve the next one? Everybody, please give it a try. The question is formula based only. But do you guys remember the formula? That is the question. It is gas absorption refrigeration cycle. It is the absorption refrigeration cycle, VA cycle, vapor absorption refrigeration cycle. It is VA cycle. So water and ammonia are used in the vapor absorption. Yes, Ramki, very soon we will be announcing that. Stay tuned. On the way, we are working out something for RRE, JE also. Now, an aqua ammonia absorption refrigeration plant uses heat from a generator. There is a generator. By condensing the steam at 120 degrees Celsius. So the temperature in the generator is 120 degrees Celsius. That is temperature inside the generator, TG. Right? The temperature maintained in the refrigerator, that is the storage space, is minus 23 degrees Celsius. That is the temperature of the refrigerator or the storage space. And the ambient temperature, outside temperature, is 27 degrees Celsius. What is the maximum possible COP? Do you guys remember the formula? Please raise your hand. If you remember the formula for maximum COP, that is TG minus T naught upon TG. TG is the generator temperature minus T naught. T naught is the ambient temperature upon TG into refrigerator temperature upon T naught minus TR. So temperature of generator is more than ambient temperature than the refrigerator temperature. So this is the formula for maximum COP of this VA cycle. If you will put the values, let us put the values and try to solve it. So generator temperature is 127 minus ambient temperature is 27. No need to convert it into Kelvin as long as we are calculating the difference of the temperature, and divide by TG. Now you have to convert it into Kelvin. This is one bracket multiplied by TR. What is TR? Minus 23 plus 273. Divide by T naught, that is 27 minus TR minus 23. This will give you the final answer. Yes, 127 minus 27 is 100. divide by 127 plus 273, 400, 1 by 4, multiplied by 273 minus 23, that is 250, divide by 27 plus 23, it will become 20 plus 23, so that is 50. So it is 5 by 4. So maximum COP is equal to 5 by 4 or 0.8. What is 5 by 4? 1.25. It is 1.25, which is correct. The answer will be 1.25. .25 will be the correct answer. Let us move further. Simple question, theoretical question. What is the answer to this one? The next one. Is the previous question clear to everyone? That is the formula based. If you remember the formula, you can do it. And HPCL is going to ask very simple formula based questions only. So what is the need of the R is to revise all the concepts, all the subjects thoroughly before appearing for your HPCL exam. There are two types of heat. One is sensible heat, another is latent heat. Latent heat is related to the phase change. The heat required for causing a phase change at constant temperature, that is called as latent heat. Latent heat of fusion, latent heat of vaporization, latent heat of sublimation. What is sensible heat? It vaporizes water into steam and vice versa. That is not correct. Why? Because it is the latent heat. Phase change is associated with the latent heat, right? Changes the temperature of the liquid or vapor. Yes, phase change takes place at a constant temperature. So when the latent heat is used, then the temperature remains constant, and sensible heat, phase remains constant, phase remains same, and temperature changes. Whenever we provide the sensible heat, or whenever we provide the heat, and if there is no change in phase but the temperature changes, then it is known as sensible heat. So it gives rise to change in temperature of the liquid or vapor without any change in the phase. Convert water into steam and superheat it? No, that is also phase change. Water into steam, and this is converting water into steam is latent heat, and steam into superheating is sensible heat. It is a combination of latent heat and sensible heat. Measure dew point temperature. It does not measure dew point temperature. Now the next one. This is wonderful question. Now give it a try. Everybody, please give this question a try. What is a diesel engine? In diesel engine, what are the various processes? It is having two isentropic, compression and expansion are isentropic, one isobaric heat addition, and one isochoric. Isobaric means constant pressure, isochoric means constant volume. So the diesel engine is having, why you guys are not responding? Why you guys are not sharing your answers? Diesel engine is the one also called as constant. It is having constant pressure cycle. So these are the processes associated with diesel engine. It is having the compression ratio of 16. Compression ratio R, which is V1 by V2 is equal to 16. And cutoff ratio RC. What is cutoff ratio? When fuel cutoff takes place, that is cutoff ratio. That is V3 by V2, that is the cutoff ratio, is equal to 2.6, because 2 to 3 is heat addition. The clearance volume of the diesel is 45 centimeter cube. If I show you the PV curve for the compression. This is pressure, this is volume, this is 1, this is 2. 1 to 2 is isentropic compression. So this V2 is the clearance volume. This is the clearance volume. We can call it as V2 or VC. So V2 is equal to VC is 45 centimeter cube. Clearance volume is 45 centimeter cube, right? Find the volume of the gas when the piston has completed 40% of the compression ratio. Find. This is the compression ratio. So when 40%, sorry, compression stroke, this is the stroke, one stroke. So find the volume of the gas. So when it has completed 40%, like this is 40%. This is the swept volume Vs, that is equal to V1 minus V2. Swept volume is V1 minus V2. So this is 0.4 Vs. So this will be, we need to find out V1 dash. That is the question. This is equal to 0.6 Vs. Yes or no? If it has completed 40% of the compression stroke, it means the remaining is 60% of the compression stroke. So what is the volume corresponding to the 40% completion of the compression stroke? V1 dash need to be calculated. Can you find out? Can we say V1 dash is equal to V2 plus 0.6 Vs? Yes or no? And what is Vs? Vs is equal to V1 minus V2. So Vs is equal to, what is V1? From here we can say V1 is equal to 16 V2 minus V2, that is 15 V2. And what is V2? So 15 into 45 is Vs. Yes or no? Vs is equal to 15 into 45. How much is that? Can you solve it? Is it? Or what you could have done is, you could have written R is the compression ratio, V1 by V2. What is V1? V1 is equal to V2 plus Vs upon V2, or V2 is Vc actually, that is equal to 16. So 1 plus Vs by V2, what is V2? 45, is equal to 16. So from here we can find out Vs. So it will be 15 into 45. Yes, it is 15 into 45. So 15 into 45 is equal to, Vs is equal to 675, isn't it? It is 675 centimeter cube. So put the values. V1 dash is equal to V2. V2 is 45 plus 0.6 into 675 will give you the answer for volume at 40% of the compression stroke. Can you solve it? Are you guys getting it 450 or not? Please do let me know if you are getting 450 or not. Everybody. Yes. Is this clear to everyone? So this is our resultant team. So it is the only, we are proud to tell you that I can proudly tell you that this is the only faculty driven platform which is very beneficial for you to have your better preparation. All the other platforms are run by some administration, some management, so they may not understand your requirements. And because this platform is run by your own faculties who are teaching you in the classes, who have appeared for the examination, who have cleared these type of examination, who are having vast experience in teaching, so it is going to be definitely beneficial for your preparation to be more result oriented. So have trust on us, give a chance to be your partner in your success journey. It is definitely going to make a difference in your preparation. Let us move to the next one. मैकेनिकल वर्ल्ड डेली नहीं है, फिर से एक सेशन लूंगा मंडे को. आई विल टेक अनदर सेशन ऑन मंडे at 6 p.m. The next session will be Monday at 6 p.m. So you join me on the Telegram. I will inform you guys there. My Telegram channel is Mechanical by Chandrasekhar, and I will share the PDF of this session also to my Telegram channel. Right? So what is the answer to this question? I will share the PDF, and those who have missed this session, then they can watch the recording also. Related to the basic thermodynamics, which of the following is true with respect to the basic thermodynamics in free expansion? What is it? Free expansion? Expansion against vacuum. In free expansion, since vacuum does not offer any resistance, yes, there is no work transfer involved in free expansion. That is definitely correct. So sometimes what happens, because of the time constraint and because of the exam pressure, students read the first option only and they find it correct and they move on. They select the option A and they move on. They do not feel the need of going through the other options, right? So you have to, whenever it is a theoretical question, when it is not a numerical question, then you should have a look to all the given option. There might be a possibility that other option may be better than the previous option which you have selected. Moreover, in numericals also always have a look to the given option, because sometimes the numerical value might be same in couple of options, but the unit might be different. So the one which is giving you the correct set of units will be the correct answer. So these are the silly mistakes you should always avoid to perform better in your examination. 100% heat cannot be converted into work. Yes, the low grade energy, heat is a low grade energy, cannot be converted into high grade energy. There is conversion of low grade energy into high grade energy completely is impossible, whereas the work that is high grade energy can be completely converted into low grade energy. Work can be completely converted into heat, but heat cannot be completely converted into work. That is given by the second law of thermodynamics. So B is also correct. Heat transfer in any finite temperature difference is irreversible. Yes, heat transfer is always an irreversible process, because heat always flow from high temperature to low temperature. The flow of heat is always from high temperature to low temperature only. So it is always irreversible process. So C is also correct. So option D will be the correct answer for this one. Option D is the right answer. I hope this is clear. Now one more statement for the Kelvin Planck. The next one, which of the following is acceptable phrase for the Kelvin Planck statement of the second law of thermodynamics? Second law of thermodynamics is made up of two basic statements. One is called as Kelvin Planck, another is called as Clausius statement. So as per the Kelvin Planck statement, what we can conclude, what is the acceptable phrase? The exact statement is, Kelvin Planck had given the statement for second law of thermodynamics that gives the concept of heat engine. What Kelvin Planck said is it is impossible to construct a cyclic device which exchanges heat only with a single reservoir. It is impossible to construct a cycle device which exchanges heat only a single reservoir. It means Q is always less than W. Q is always less than W. 100%, the thermal efficiency cannot be 100%. So there has to be another reservoir where the remaining heat must be thrown. So complete conversion of heat into work is impossible. That is what is Kelvin Planck statement. So which of these is correct? Which one of these is correct? Hi Mani Selvan, welcome. The session started at 6 p.m. today. We are about to wind up. An engine has to reject the heat. Yes, that is correct. The heat engine has to reject the heat to the low temperature reservoir. The complete conversion of heat into work is impossible, or the efficiency of a thermodynamic cycle cannot be 100%. Statement B says an engine can produce work without accepting power. That is not the correct Kelvin Planck statement. That is not the acceptable phrase. Even though it is correct, because heat always flow from high temperature to low temperature naturally. So no need to have the power. No process can produce more work than the amount of heat input. That is also true. No process can produce more work than the amount of heat input, or no process can produce even the equal work. Even the equal work as that of the amount of heat input. So the best acceptable phrase is the engine has to reject the heat to the low temperature reservoir. Option A is the correct answer for this. I am giving you one assignment question and then we will end our session. This is your assignment session. Try to solve this question on your own and share me the answer either to my Telegram channel or to the comment section. So in the next session, most probably I will have another session on Monday at 6 p.m. I will inform you the timing and the date when it gets finalized. Then we will discuss this question as well, and we will bring more questions from the entire thermal as well as fluid mechanics and heat transfer. All right. So this is all from my side. I will share you the PDF of this session. You can join that. You can follow us on the Telegram also. You can scan this QR code and you can follow us on Facebook also, and the mail ID for all your queries is support@resultant.in. We are running civil and mechanical branches in our Resultant platform. If any one of you or your known is interested to be part of our paid courses, then you can note down the mentioned number. You can connect with us. We will be more than happy to help you out in every possible way so that you clear your competitive examination, whether it be GATE or any other PSUs. With this note, let me take your leave for now. Thank you for joining us, guys. Take care, stay safe, stay motivated, and do not forget to like, share, and subscribe our Resultant YouTube channel. It will definitely be helpful to us as well as other students who can watch, and it will helpful to you also, so that all the notification will be shared with you. All right. So thank you very much for joining in once again, and take care. Jai Hind.